In the last class, we asked the big question, an 8112, what is a network? Today, we zoom into the one you meet more than any other, the LAN, the local area network. This is the network in your home, in your office, in your school, and 82124, the devices in a single place connected so they can talk to one another. It is the smallest complete network there is, and yet, understand it well, and you understand the building block from which the entire internet is made. So today, we will see exactly what a LAN is, meet the switch that sits at its heart, learn how every device gets a permanent name called a MAC address, and follow a single message as it finds its way to precisely the right machine. This is where networking truly begins. Here is what we will understand today. First, what a LAN actually is. Second, the devices that live on it. Third, the switch that connects them all. Fourth, MAC addresses and why every device has one. Fifth, wired and wireless LANs. And sixth, how a LAN differs from a wide area network. Let us begin. Let us start with the definition and keep it simple. A LAN is a network confined to one location. That single word, an 80/12, location and 80/12 is the whole idea. It is local, limited to a small, defined area, rather than stretched across cities or countries. And that place can be a home, with your laptop and phone and television, or an office, with dozens of computers and printers, or a single building, floor by floor. Whatever the setting, the defining feature is that everything is close together in one place. Because the devices are close, they can be wired directly to one another and talk at very high speed with almost no delay. That closeness is exactly what makes a LAN fast. So the takeaway, a LAN, a local area network, connects the devices in one location, an 82/12, a home, an office, a building, an 82/12, so that they can talk to each other directly and quickly. Now let us look at what actually sits on a LAN and 82I12. The things doing the talking. We call them hosts. A host is any end device that sends or receives data on the network, your laptop, your phone, a printer, a server, a smart television. If it produces or consumes information on the LAN, it is a host. And here is the crucial detail, an 8012. Every one of these hosts has its own address. Without an address, a message would have nowhere to go. The address is what lets you aim a piece of data at one specific machine rather than shouting it at everyone. So a LAN is really a collection of addressable hosts, each one individually reachable. Keep that word, host, because you will hear it constantly, an 8212. It simply means an end device on the network. So the takeaway, every device that sends or receives on the LAN is called a host. And each host carries its own address so that messages can be aimed precisely at it. Now we meet the single most important piece of hardware on a LAN and 8212. The device that ties everything together. It is called a switch. Picture the switch as a box sitting at the very center of the network. It has many ports, N8212, many sockets, N8212. And its whole job is to connect the hosts to one another. Every device on the LAN plugs into the switch, the laptop into one port, the printer into another, the server into a third. The switch does not do the work of the devices. It is the meeting point through which they all reach each other. So instead of wiring every device directly to every other device, an 8212, which would be an impossible tangle, an 8212, each device simply connects once to the switch, and the switch handles connecting them together. It is the hub of the local network. So the takeaway, at the center of a LAN sits a switch, an 8205. Every device plugs into it, and it is the switch that connects them all to one another. But how does the switch know which device is which? For that, we need to meet the address it uses, an 8212, the MAC address. A MAC address is a unique hardware identifier, burned permanently into every network device when it is manufactured. No two devices in the world share the same one. Think of it as the machine's permanent, built-in name and ODAT swal. It does not change, wherever the device goes. And the switch puts these to clever use. As devices talk, the switch learns which MAC address is reachable through which of its ports, and it builds a little table in its memory. This address is on port 1, that address is on port 5. It learns the layout of the network by listening. So, the MAC address is the fixed identity, and the switches table is the map that connects each identity to a physical port. So the takeaway, every device has a unique MAC address and A200 A2 half, its permanent hardware name and A200 A2 half, and the switch learns them so it knows exactly which device sits on which port. Now, let us put it all together and watch a single message travel across the LAN, because this is where the switch's cleverness really shows. Say your laptop wants to send something to the server. It builds the message and stamps it with the destination and A200 tool, the server's MAC address and A200 tool and hands it to the switch. The switch looks at that destination MAC address and checks its table. It finds the matching entry and A212. That address lives on, say, port 5 and A212, so it knows exactly which port leads to the server. And here is the elegant part. The switch sends the message out of that one port only. It does not blast the message to every device on the network. It delivers it privately to just the intended machine. The printer and the other laptops never even see it. So the takeaway, the switch reads the destination MAC address and forwards the message only to that one device, an A212. Efficient, private, and precise, rather than shouting it at everyone. A LAN can be built in two ways, and it is worth knowing both, because you use each of them every day. The first is wired, using a standard called Ethernet. This is the physical cable, an A212 valve. The network cable you plug into a laptop or a wall socket, an A212 valve. And it is the classic, fast, rock-solid way to join a LAN. When reliability and raw speed matter most, Ethernet is the answer. The second is wireless, using Wi-Fi. Here, devices join the LAN through the air, connecting to an access point and A212, the wireless base station and A212, instead of a cable. It trades a little speed and reliability for the freedom to move around. But notice, whether a device joins by cable or over the air, it is still on the same LAN. Wired and wireless are just two doors into the same local network. So the takeaway, a LAN can be wired with Ethernet or wireless over Wi-Fi and 802.112, two different ways to join, but the same single local network underneath. Finally, let us place the LAN in context by comparing it to its larger cousin, so the boundaries are clear. A LAN, as we have seen, covers one location. It is private, it is under one owner's control, and because everything is close, it is very fast. That is its whole character, small, local, and quick. A wide area network, an 802.112, a wide area network, an 802.112, is the opposite in scale. It spans cities, countries, even the whole globe, linking distant places together. The internet itself is the largest wide area network of them all, a network of networks stretching across the entire planet. And the relationship between them is the key insight. A wide area network does not replace LANs and 84FOL. It connects them. It is the long-distance route system that joins one local network to another, far away. So the takeaway, a LAN covers one place, private and fast, while a wide area network links many LANs together across great distances, and 8200, the internet being the biggest one of all. Let us close by seeing why this small local network deserves so much of your attention. The LAN is the fundamental building block of all networking. Every large network you can name, and 8252, a company's global network, a university campus, the internet itself, and 8252, just at its heart, just many LANs joined together. There is nothing more basic and nothing more important to get right, which is exactly why we learn it first and learn it thoroughly. Understand how a single LAN works, and A202.4 hosts, switch, MAC addresses, delivery, and A202.4, and the far bigger topics ahead will feel like natural extensions rather than new mysteries. So do not dismiss the LAN as too simple. It is the seed from which every network grows, and mastering it is what makes everything after it click into place. So the takeaway, every larger network is built from LANs joined together. So mastering this one local network is the foundation on which the rest of networking rests. Let us gather the whole class in one breath. A LAN is a local area network, and 85v2. The devices in one location, connected so they can talk. The end devices are called hosts, and each one is uniquely addressable. At the center sits a switch, into which every device plugs. A MAC address is a device's unique, permanent hardware name, and the switch learns them. The switch delivers a message only to the device whose MAC address matches an 800 of private and precise. A LAN can be wired with Ethernet or wireless over Wi-Fi, while a wide area network links many LANs across distance. Next class, IP addresses and how devices are named across networks. One idea at a time. That is the LAN, an A2 R4 R4 off, one location, one switch, and every device connected and precisely reachable. It is the smallest complete network, and the foundation of every larger one. Hold this picture clearly: an 800 of hosts talking through a switch that knows them by their MAC addresses, and 804. And the whole internet, for all its scale, will start to feel like something you can understand. We will see you in the next class.